Appreciate you. Today's the 8th. And I didn't really, I kind of forgot that we had to do this. And then as I dug the pre-quiz or the practice quiz out, then I remembered, oh snap, there's a whole section at the back where you have to know how to do two-way tables. They're actually really, really easy. So before we talk about what a two-way table is, let's draw one, and then I'll explain to you why it's called a two-way table. Once you understand the reasons behind why it's called a two-way table, you realize what a hilariously obvious, like what else would we call it? So they look like, kind of, honestly, yes, like this. Oopsie. Right. Choose the pen tool like you've done this before.
Oh.
What?
Toby, you're really willing to start that fight?
No, I don't think we're going to have this silly debate, are we? Really? Like, does anyone really care?
Yes. You're talking to yes.
Yeah.
No, Chevy wins all the way. Sorry. Yes. 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 We have a Ford Expedition and it's having issues already, and it's like brand new. So I don't want to hear it. And trucks, we've had issues with trucks out on the farm.
So I really do not want to debate the merits of Ford versus Chevy, because I'm one of those guys that honestly, I'm sorry if I don't care. I couldn't care less. So I'm going to drive whatever gets me from point A to point B. And I realize that, and like you said, it's country kids. And so a lot of you guys have been raised like with the little picture of Calvin, you know, peeing on the Ford logo or peeing on the Chevy logo. Hey, you do you. But I don't care. And I don't really want it to be. Yeah, I'm going to try to explain that. I just want to make sure we're clear that I don't want to talk about the merits of Fords versus Chevys. And now I can explain and answer Peyton's question. I was trying to come up with a way to come up with like new versus old. So this is after the year 2000. So an example of this would be like manufactured in like 2001, 2002. And this one below is 2000 and earlier. So that would be like a truck or a whatever that was manufactured in like 96, 97, 98. This box up here is never going to get used. So when we talk about a two-way table, so the reason we call it a two-way table, it's almost so obvious that I hate to say it, but I will, is that we use it to classify information in two different ways. So when I go through and I fill in some numbers for this, you could say, like, God bless you, let's say I put like 8 here. Understand that that 8 is being classified. That's some data being classified two different ways. I could say that the number of trucks in this box is representative of a truck that is a Chevy and also was manufactured after the year 2000. So when you can come at a piece of information from two different ways, you use what's called a two-way table. We're classifying data two different ways. We're classifying it by the make, Ford versus Chevy, and we're classifying it by the year, before 2000 or after 2000. Does that make sense why we call it a two-way table? Okay, so let's continue to put some numbers in here. So you're going to be asked some questions about, and when we get to our IXL assignment, which I'll be curious to see how that goes. I always mean to use IXL more, but this is a perfect time to use it because it does a good job with two-way tables, whereas Delta Math does not. It has a pretty limited offering. So when we get to IXL, you'll be asked all sorts of different questions about this. So let's talk first about the total. when you think about this, so let's say that you took a survey of a bunch of people who drove trucks, and you asked them, do you drive a Ford or a Chevy? And can you tell me what year it was manufactured in? And then you tally them off, and eventually you fill in this two-way table. Could you tell me, based on this table, how many people were asked the question? Close.
100.
Nope. How many people said, I drive a Ford that was manufactured after the year 2000? How many people said, I drive a Chevy that was manufactured after the year 2000? So on and so forth. So if I go through and I say, okay, 10 people said this, 8 people said this, 9 people said this, and 13 people said this. If you add all of those together, which is what, of course, logically you would do, then you get 10 plus 8 is 18, 18 plus 9 is 27, 27 plus 13 is 40. So first things first, whenever you read a two-way table, you want to first get the grand total out of it and be able to say, this is the total number of people that were in the table. Good so far? Say again? Good, thanks, bud, appreciate it. Now, if I asked you a simple question like this, so here it goes. Let's say these 40 people, I don't know, sitting in a room someplace or whatever, and I just randomly picked one of them out. What would be the probability? By the way, can we just change this to be new and old? Are you guys okay just for the simplicity of our conversation? I was actually just going to write it down and I decided not to. But so now that you've sat through this, we'll agree that new means it was manufactured after the year 2000 and old means it was manufactured 2000 or before. Got it? So this will just make it easier for us to talk. So if I just randomly picked one of the people, the 40 people in the room, blindfolded myself and said, you, what's the probability that I picked someone with a new Chevy? Ready, go. Nope. How many people are sitting in the room? How many people are sitting in the room?
40.
So 40 is definitely the bottom of my fraction. How many of those 40 people drive a new Chevy? How many people drive a new Chevy? Right there. 8 out of 40.
I was so confident.
I know you are. I'm so sorry. Say again? And of course, we would reduce it down. So we can say that there is a 1/5 probability that I would pick someone at random who drives a new Chevy. So far, so good? Okay, how about this one? What would be the probability if I just picked someone at random that they drive an old truck? Not a race. Okay, everyone take your time and let's give everyone a chance to process.
You
An
just said
old-
old truck.
An
Which
old
one?
truck. Just an old truck. First off, how many people are there in the room?
40.
Thank you. So that's going to be the bottom. Now, how many of the people on this table drive an old truck? There's your 22. That's 9 people drive an old Ford. 13 people drive an old Chevy. And like Shirai hit the nail on the head, she said, well, which kind of truck? Old. And if that's all I can say, then all I have to do is look at this row that says old. And that means that I add the Fords and the Chevys together, and my answer would be 11 out of 20 like that. Got it? Good? Still good? Okay, let's ask this again. Let's go a different direction. This time, what's the probability if I blindfold myself and just point to a person, boom, that they drive a Ford? Now you're getting the hang of it. If I just say Ford, then there's no mention of is it old or is it new. Then I just add up all the Ford people who are in that big yellow bubble. 10 plus 9 is 19. So my answer is 19 out of 40, which can't be reduced.
Are we doing two tables? Because I know there were like 3.
Just 2 ways for now. Yeah, that's all. So far, so good?
Yep.
Okay. Now I'm going to start writing these down because they're going to get just a little bit more difficult, but not much. Yes.
Are they only going to see it in 2 ways or are they going to be 4?
That's what he just asked. We're just going to do 2-way tables for now. No, it's fine. I'm not trying to. Just telling you that's what it is.
Okay. I saw a cat on the side of the road with that picture on.
That's a real catastrophe. Not a very perfect way to start your day. Sorry. Sure.
Yeah.
Okay. How about this one? If I pick a person at random, what's the probability that they drive a Ford or an old truck? We've talked about this before, and the word or comes up, and don't just shout an answer, okay? There's no benefit to anyone if you do that. If you guys remember the or problems where we had some numbers that got counted twice, you don't have to say yes just to be polite. Do you remember how sometimes, like when we were doing the card problems, if I said, what's the probability that we get like a 3 or a striped card? What would you do if there was one card that was 3 and also striped? Do you remember how we had to subtract it out? The same logic is going to apply here. So before, again, you give me an answer, because that's going to be of no benefit to me in this lesson right now. Just let's answer the questions in pieces. How many people in the table drive a Ford? So I'm going to write 19. How many people drive an old truck? Very good. So at this point in time, by the way, of course, the bottom is always going to be 40, right? In this case, 40 out of 40, out of 40, out of 40. So if I add those people together, 19 plus 22, I would get 41. But that doesn't make any sense. What do I have to do? Why 9? Because these people, right? I should not have vandalized this, or I got to fix this. Hold on a second. I should have erased that right away when I had a chance. Dang it. There we go. Fixed. Good. If you think about like this, let me color code this for you. Here are the people that drive Fords, correct? In the red box. And in this purple box, here are the people that drive old trucks. These people, and you guys said it right away over here, these people right here got counted twice, didn't they? And so instead of doing 19 plus 22 and sticking 41 over 40 like a ding dong, because that doesn't make any sense, you actually have to subtract out those 9 people. So we're going to do, yes, 19 plus 22, which is 41, but we then have to subtract 9, which is what? So the answer is 32 out of 40, which if you divide them both by 8 gives you 4/5. Got it? So when IXL or anyone asks you for or, you have to add a couple of categories together and then subtract where they overlap. How about this one? So I'm going to erase the total. We know the total's 40 by now. How about this one? What's the probability that if I pick a person at random that they drive a new truck or a Chevy? This is confusing unless you're willing to work along with me and take good notes. So here we go. I'm going to color code this again because I care about you. How many people drive a new truck? So I'm going to draw a box because to me, this box is uber visual. So there's 18. How many people drive a Chevy? Good. And there's another box. Now you cannot deny me this, that there's an intersection where there's people that are in both boxes, right? And how many of them are there specifically? Good job, you guys. So we're going to take the 18 plus 21, but we have to subtract 8 because they got counted twice. What's 18 plus 21? And what's 39 minus 8? 31. So the answer to this one is 31 out of 40. Does that make sense? Okay. I'm doing some serious erasing here. It is. Very good. So what is the probability if I pick a person at random that they drive a truck that is a new truck and is also a Chevy? Notice the word and. This makes this problem 1,000,000 times easier. You want to give it a shot? Go ahead. You don't have to add anything. You don't even have to add those because look, if I pick on you and I call on you for you to drive a truck that is both new and a Chevy, You can only be those people right there. Good. So when it says and, we don't have to do any addition at all. We just look for a very specific place in the table. These people that I've circled in yellow are the only 8 people that can say my truck is new and it's a Chevy. So the answer is simply 8 out of 40. Got it? Are you still with me? Nope. To drive something that's new and Chevy, you have to be these 8 people right here. Your truck is new and it's a Chevy. So ors are tricky because you got to add and subtract. Ands are just look for where 2 boxes would cross and call it good. Now this last part is a little bit weird. This is where you really should copy some stuff down. If you haven't been already, I'm going to start using my keyboard here. So ready? What is the probability that I pick a person who drives a Chevy given that their truck is old? Really, I'm going to wait while you write that down. I don't want any answers until I know you've put this in your notes. These are called conditional probabilities. So there's a condition that has to be met. So this word is really important, given. And there's about a 76.2% chance that I'm about to really lose you. So when it happens, or if it happens, just tell me and I'll go back and try to explain this again. So if I say I'm going to pick a person and I want to know what's the probability that they drive a Chevy, given that they drive a truck that is old, the first thing I can do is this. Watch carefully. Watch carefully. Those people are no longer in the table. They no longer count because the condition that has to be met, it says given that their truck has to be old. And these people that I've let survive in the table are the only people who drive an old truck. So what that means now is for the duration of this problem, for the rest of this problem, my denominator is no longer 40. My denominator is 22. Because if it says given that their truck has to be old, again, only the people in the yellow oval drive old trucks, correct? So this entire problem now, the entire probability is founded upon having to be one of those 22 people first. How many of those 22 people drive a Chevy? So this is a conditional probability and it's 13 out of 22. Does that make sense? Mm-hmm. The given that basically takes the pool and shrinks it down. Let's do a different one. How about let's do the probability that someone drives an old truck given that their truck is a Ford. So right away, it's the given statement that shrinks the denominator, shrinks the pool. How many people in this table drive Fords? Mm-hmm. Then the bottom of our answer is 19. Let's get that out of the way right now. If it says given that their truck is a Ford, then only these 19 people now matter. These over here are dead to us in this problem. They don't drive Fords. Now, of those 19 that I haven't crossed out, how many of them would we say drive an old truck? Therefore, the answer to this one is 9 out of 19. Always reduce. These last few, though, haven't been reducible because of the 19. It's pretty uncooperative, right? That number. Do you see the difference between those? And the first ones, we're just looking for a particular category. This one, we're looking for a category, but it's a subset of another category, right? Mm-hmm. Correct. Yeah. Whatever it says after the given is like your new population. That's the new group of people that you're working or you're looking for. Okay, let's do another one. Let's do They've got to erase this sort of drive me crazy. Get out of there. Boom. There we go. Let's do drives an old truck. Given that it's let's change. No, you're writing this down. I don't want to be rude. So we'll do another one after this. Let's do drives an old truck. Given that it's a Chevy. So like Aiden has figured out, it's really how do I crack the code? So Aiden figured out that whatever comes after the word given determines our new total bottom number, right? So if it says given that it's a Chevy, how many Chevy drivers are there? Right here. So the bottom is 21. Everyone I've circled up there is a Chevy driver, correct? 8 plus 13 is 21. How many of those 21 people are Chevy drivers? Or excuse me, old truck drivers. 13, so it's 13 out of 21. So far, so good. So let me show you something real quick, and I'm just going to keep the recording going here just so you can see. Assuming I have this open. Good. Can you read this? Is this, do I need to zoom in a little bit? So the skills that I wanted, the first one is, you guys have done this before, how you go into IXL and then you go to search and then you can just type in a code, right?
Some of us didn't ever get timed into it because our English teacher couldn't figure out our codes and stuff.
Okay, I should be able to help you. All right, so take a look at this. The research department of a board game company surveyed some shoppers at a mall. The team asked shoppers how often they read the news, among other questions. And then the team played a memory card game with the shoppers. They recorded how many cards each shopper remembered. So you can see the two ways that the people are being categorized is going across this way, how many cards were they able to memorize? Going down this way, they were categorized by how often do they watch the news or read the paper or whatever. So the probability that a randomly selected shopper remembers 1 to 3 cards, and this is the thing, this is the condition that has to be met. It says right here, like Aiden pointed out, given that the shopper reads the news 0 times per week. So that right away keeps only these 9 people in the running. Do you see that? That's what shrinks the population. How many of those 9 people remembered 1 to 3 cards? So the answer is 7 out of 9. Anything that comes after the word given determines your full population. Got that? The other skill I wanted to show you before I cut you loose here was 93R. And I'll put these up here for you here in a little bit. But like, so Victoria is a pediatrics nurse, conducts the first neonatal exam on newborn patients. She makes note of the newborn's height, weight, eye color, heart rate, among other things. So here's what she did. She categorized the data in 2 ways. Number 1, she categorized it by the color of the baby's eyes. And number 2, she categorized it by the heart rate. That's what this particular set of data that you see is. These are the 2 ways it's categorized. What is the probability that a randomly selected baby has a slow heart rate and has blue eyes? What's the first thing I need to know before I can even go in here? I see some of you on your computers, and already it's a problem because that just tells me that I'm going to have to answer these questions again. So just give me a couple more minutes. I'm not the kind of guy who says you have to go home and work and get this done, am I? And I've never been that guy. So don't feel like you have to compete with me. What's the first thing I have to do in a 2-way table like this? I got to figure out the total. So help me with my addition. What's 3 plus 2? What's 5 plus 6? What's 11 plus 4? So that to me is worth like just writing down somewhere, is to know, okay, that the table has 15 people. So what is the probability that a randomly selected baby has a slow heart rate and has blue eyes? Does everyone see that that is exactly referring to those 2 babies? Do you agree that those 2 babies right there have blue eyes and a slow heart rate? So the answer that I'm going to type in into the box here is I'm going to type in 2/15. And notice it says to just leave it as a fraction and simplify it. Let me see if I can find an or. I know there's a lot of ands in here, not a lot of oops. Okay, let's do this one. Oh, look, it's a three-way, but that's okay. We're not scared. I mean, it's a two-way table with with three categories. Good. This one says or, so it's why I wanted to do this one with you. And then I swear I'm getting out of your way. What's the probability that a randomly selected club member prefers paperback books or does not read 1 hour per week? Again, what's the first thing I need to do? Yeah, figure out how many people participated in this survey or whatever. So 4 plus 8 is 12, plus 9 is 21, plus 5 is 26, plus 4 is 30, plus 5 is 35. So there were 35 people surveyed or studied or whatever you want to call it. So here it goes. Paperback books or does not read 1 hour per week. Or means I have to look at all the people in this category first. So paperback books are going to be the people in the red box. How many people are in the red box? 18. Very good. Does not read 1 hour per week is all of these people. To say does not read 1 hour per week means you either read 3 hours or 5 hours per week. Got it? How many people are in the green box? Try again. How many people are in the green box? Oh, yep. 9 plus 4 is 13, plus 5 plus 5. Thank you, Mr. Roscoe. 23. Now, how many people are in both boxes? 10. So we go 18 plus 23 is 41. But then we have to take away these 10 people because they're in both boxes. And that is 31 out of 35. Got it? So I'm going to write this and then I'm going to get rid of, I'll try not to leave this up here forever, but these are the 2 IXL skills that I want you to do today. I want you to do 93R and I want you to do BZZ. Got it? And I know we haven't done any IXL yet this year, but you know how you get that, what's it called, the SMART score, I think? And let's shoot for SMART scores up above 90. And if you're really feeling good, you can take it up to 100. Okay, so your username, oh, I got to pause my recording or end it. Hang on a second. Stop